Okay, something's come up at work today that seems to confuse people occasionally, so I thought we'd have a quick look at it. Torque wrenches, extensions, and if you're using a torque wrench with a special adapter on the end of it, how you calculate what you need to set on the wrench to get a specific torque on the fastener. It's actually dead simple. First you need to know what torque really means for this type of torque wrench. It's going to be pretty obvious to most people that if this is the fastener that you need to rotate, apply torque to, we put a wrench on it, like so. Our wrench has a set length, and we pull on the wrench here. We're going to rotate the fastener clockwise here. And I think it's pretty obvious to most people that if we put our hand here, we'll have to pull harder to get the same torque on the fastener. And that's because torque is a function of the force that you apply and the perpendicular distance from the line of action of the force to the fastener. So the most efficient way to use this wrench on this fastener is to put your hand as far out as you can and pull at 90 degrees to the wrench. Okay, that will be minimum force for maximum torque. If you can't do that, if you're all skewed up and you're having to pull this direction, you have to pull a lot harder, because the perpendicular distance to the line of action of the force comes up here at a point where it becomes perpendicular. We'll draw this on a bit of paper. Is significantly less. So, and you can see that some of your pull has been wasted by just pulling the nut this direction, in which direction it isn't going to move. So you're wasting some pull. Sometimes you're stuck and you can't do anything else. That's all you can do. It means you're going to have to pull harder. And the same thing is true of a torque wrench. All right, and the reason for that is when I set a figure on here in foot-pounds, for example, the torque, say I said 100 foot-pounds, here will be equivalent to me taking a bar 1 foot long and pulling 90 degrees with a force of 100 pounds. I think most people probably know that. Now this torque wrench is not a foot long to the center of the handle, it's 14 inches. Okay, so take my word for it for a moment. This is longer, so requires slightly less force at the handle. So to get 100 foot-pounds here, I'm going to be pulling 100 pounds times 12 over 14, which is about 85 pounds. So when I set 100 foot-pounds on the dial here, what that's actually telling me with this torque wrench is that it will take a force of around 85 pounds at the center of the handle, and that's what it will click at. Right, so far so simple. Okay, now I have applied my extension, which I need for whatever reason, either to get on the nut or to increase the value of the wrench. The problem is the torque wrench doesn't know that I've got the extension on, so it's always going to click when I'm pulling here with 85 pounds. But now my force times perpendicular distance to the line of action is going to be 85 times this much longer length here. Alright, so this longer length all the way from the center of the nut here to the center of the handle here happens to be 26 inches. So we know the wrench is going to still click around 85 pounds here. It doesn't know any different. And my torque in inch pounds, because we've measured in inches and pounds at this nut here, is going to be 85 times 26. 26 inches, did I say? I'll check that. And we'll work that out in a second. Okay, I quickly worked that out. 85 times 26 was 2,228 inch pounds because we got 85 pounds 26 inches, so the units are inch pounds. Dividing that by 12 gave me about 185 foot pounds. Okay, inch pounds divided by 12 is foot pounds because there's 12 inches in a foot. So when I'm set 100 on the dial here with this extension on, I'm actually torquing the nut to 185 foot pounds. Okay, 100 foot pounds set on the dial, 185 foot pounds on the fastener. And I think we can do what it's usually important when you're torquing something, so you've got to be careful when you're doing this kind of shit. You can end up breaking things really badly, but if you were to double this distance from the center of the handle to the head with an extension, I think you could see that that would double the torque, because you're doubling the distance to the line of action of the force. Okay, now we haven't quite doubled it here, and we've gone from 100 to 185 foot pounds. That tells me that I haven't made a gross error in my calculations. I'll probably do the calculations again and triple check them and get someone else to check them if it's a really critical fastener. But it's good to have an idea, right? If you double the distance from the handle to the head with an extension, you're going to double the torque. So if you had half the length of this extension, you'd be adding 50% to the torque roughly. So you can get an approximate idea of whether your calculations are right from that, and that's pretty important in case you miss out a decimal point or really screw something up like we all do at the end of a long Friday. Okay, I think what we'll do now is we'll look at some more useful formulas, because what we really want to know is when a torque is specified for the fastener and you have an extension, what do you set the wrench at? And there's an easy way to work that out if you can do a little bit of maths. Just a note of caution, any of these calculations, once you've done them, are valid for one wrench and one extension, because if I get a different torque wrench now with a shorter handle, this may sound really stupid and obvious. This torque wrench, for example, is 10.5 inches to the center of the handle. So if I set 100 foot pounds on this one, I'll be pulling with, it will break with more than 100 pounds pull at this point on the handle. Okay, and that's going to confuse us a little bit. This is going to be 100 times 12 over 10.5. Okay, if it were 12 inches long, it would be exactly 100 pounds. At 10.5 inches long, we need to multiply by 12 over 10.5 to get the torque, and I'll work out what I'll quickly work that out. With 100 pounds set on this wrench, I'll be pulling in the middle of the handle 90 degrees to the fastener with a force of 114 pounds to get 100 foot pounds here. Now if I put the same extension on this wrench, it's only about 23 inches long. Was it 23? Can't remember. Let's measure it again. Measure twice. There's 22. Yeah, 23 inches. Measure twice, mess up once. And 114 times 23, I think, is 218. And again, that ties in with our kind of rule of thumb, because we have more than doubled the length of this wrench. We had 100 foot pounds set. Distance from the handle to the fastener has more than doubled. Okay, that's longer than two spans there. And we've more than doubled the torque. We've gone from 100 to 218. So for every combination of wrench and extension is unique. You can't say that this extension increases the torque by any fixed amount. It's a ratio dependent on the length of the torque wrench and the length of the extension. The ratio is actually length of the torque wrench to the total length. It's easier to look at like that, but we'll come to that later. And the other thing is, which is pretty obvious, you've got to keep it all in a straight line. If you tog it like this, okay, you'll be pulling here. Take the line of action of the force until you get a perpendicular distance here. You could calculate that by trig if you had to, but you wouldn't even want to. So you got to keep it all as straight as possible. Okay, there are times when you can't. You've got to use all sorts of weird, wacky trigonometry and calculations, but it's best to design things so you can. Anyway, we'll go and look at a sheet of paper which is boring, even more boring than this, and see how we go. Okay, to recap, we had a torque wrench with no extension. It was 14 inches long, and we established that if we set the torque wrench dial to 100 foot-pounds, that to produce a torque of 100 foot-pounds on a fastener here, torque T, we would need a force in the centre of a handle 14 inches from the head of around 85 pounds. And that's always true when this torque wrench, this particular torque wrench of 14 inches head to centre of handle, is set to 100 foot-pounds. It will always take about 85 pounds pull here to click it. Okay, and that's where we should always pull on the torque wrench, centre of the handle, 90 degrees, good practice. It's how things work. So we established that with our torque wrench here, when we add an extension, the wrench, being kind of stupid, doesn't know that our distance from force to fastener that we're torquing has increased. And since torque is force times distance to fastener, not distance moved, distance, perpendicular distance from the line of action of the force to the fastener, the torque is increased by adding the extension. So our 100 foot-pounds became 185 foot-pounds at the end of this extension, because our total length was 26, our original length was 14. Had it been 28, it would have doubled to 226. Okay, we've kind of established that. All we really need is a formula to go the other way. If we know, let's work it backwards, say we want 100 pounds with the extension, foot-pounds with the extension, we want a formula to know what the torque wrench setting is, and that formula is the torque wrench setting is the required torque times the torque wrench length, all divided by the total length. Okay, and let's just work that so that we can kind of prove it. Okay, here goes my dodgy maths. I'm complicating things a bit now. Since often you end up measuring in inches with this, I'm going to convert my required 100 foot-pounds to 1200 inch-pounds. Feet to inches we multiply by 12. The pounds don't matter because it doesn't change. So just to make things easy, and because we're measuring in inches and pounds, I'm going to put this up to, I need 100 foot-pounds at my fastener, 1200 inch-pounds, okay, because that's what we're measuring in. So formula, torque wrench setting is required torque times torque wrench length divided by total length. So torque wrench setting is 1200 inch-pounds times 14 inches, the torque wrench length, divided by 26 inches, the total length. That comes to 646 inch-pounds. Now, if I want to set the torque wrench in foot-pounds, I divide by 12, go back to where we started. And that comes to 53.8 foot-pounds. So if I didn't want, okay, I wanted 100 foot-pounds, but I'm using an extension, so setting the torque wrench to 100 foot-pounds is no good. It will give me a higher torque. I use that formula to establish what I want to set the wrench at to get 100 foot-pounds. Shit, that was confusing, but I think you get a picture. Just use the formula. Setting is required torque times torque wrench length, all divided by the total length. Thanks for watching. Good night.